Hello and welcome to Soft Papers channel. I am Godfrey. In this video, I am solving Cambridge AS Physics. Our topic is Measurement Techniques, 2019 October. I encourage you to consider doing your revision topic-wise. Read a given topic and come attempt the questions when the content of that topic is fresh in your mind. This way, you will be you'll get the most out of the topic. This is a sure way of getting your A star if that is your goal. Good. If you haven't already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way, you'll be notified every time I upload a new video. Let's get started. Our topic today is measurement techniques. Of course, this will always help you know from which paper the question we are dealing with was setting. This was paper 1, paper 1-1. This was question number 4, October-November 2019. Number 1, a student intends to measure accurately the diameter of a wire, known to be approximately around a millimeter. And the internal diameter of the pipe known approximately to be 2 centimeters. What are the most appropriate instruments for the student to use to make these measurements? For the wire, I recommend a micrometer screw gauge, right? And of course, for the pipe, since the diameter is 2 centimeters, I recommend calipers. So you'll need calipers. So the correct answer here is C. Number 2. Question number 2 was set on paper 1-1. Question number 5. The power P dissipated in a resistor of a resistance R is calculated using this expression. P is equals to V squared upon R, where V is the potential difference, PD across the resistor. The percentage uncertainty in V is 5% and in R is 2%. What is the percentage uncertainty in P? Of course, we are told that P is this one, V squared upon R, and we know that the percentage uncertainty of P is equal to the percentage uncertainty of volts, but since volt is squared, of course we get volts multiplied by 2 plus the percentage uncertainty of R. When you're given the percentage uncertainties, you just add them straight. If you're given absolute uncertainties, then of course you have to find the percentage uncertainty first to do the addition. So for percentage uncertainty of V is 5, so then it will be 2 times 5, plus percentage uncertainty of R is 2 plus 2. Therefore, this will be 10 plus 2, giving us 12%. And the right answer here is D. Number 3. Number 3. And please, you can get this same paper we are solving here from this site, softpaper.co.uk. Always practice working out these questions with me. It is good to watch this video, but remember, when you practice, you build muscle, and it is a good way of learning. Of course, the site I'm talking about is right here. This is soft papers. Soft papers, you'll come to A-level physics 2019 topicals. This is where you're going to be coming here. Of course, we are doing measurement techniques in November. Of course, there's November and there's June. So measurement techniques is right here. So this is the paper I want you to download. You'll click here and click here get all solved topicals in a zip folder. You'll get all these topicals in one zip. Of course, when you click there, you'll come to this page. Let me just help you out. Of course, this is 2019 September. November. There's 2018, 2017. All these topicals are available for you if you so wish. So we are in 2019 November AS multiple choice. So this is what I want you to be able to click. It's basically £10. You can ask your parents to help you with this. Get as many topical questions as you can. Yeah. Get also for June. Get also for 2018 November and June 2017 and so forth, and practice solving this question. This is the sure way of getting your A star. It's a small price to pay for your A star, so let's do it. I also do online tuition. If you want my assistance, I'll be glad to help. I'll do online tuition at SP Academy. This is the site that I would like you to get in touch with me through. SP Academy. SP Academy is this site here. SP Academy is this site. SP Academy. I'll need you to, of course, visit the site, have a look at it. Of course, it's an easy site to understand. Of course, you can select your location here. We teach students all the way from all over the world. Of course, you can choose your course here, right here, whichever course you are interested in. And of course, you can search for the teacher that is available for that course. Of course, the courses that you're offering are this: ICT, Maths, Physics, Biology, and Chem. Of course, you can look at the student guide to familiarize yourself with your dashboard functionalities. You can also watch this video to get familiar with our online classes. And when you are ready, you need to sign up. You need to register. And of course, this is where you come. You just register. We will send you an email to activate your account. Then you can be able to sign in. And once you get into your dashboard, then you can click Find a Tutor, and you'll get the teachers that are listed here. Our teachers are usually well vetted. We are all professionals currently teaching in premier schools, so there's no reason why you should be hesitant. Go ahead, engage us, and we'll be able to help you get your A-star and get to the university of your choice. One-on-one, if you are one student, one-on-one, my charges are usually 35, very fairly charged per hour. If you come 4 students in my class at 1, can gang up with your 3 friends, then you'll be 4. Then I'll give you a fair price of £10 per hour. Let's do this and let's help you guys get your A-star. I've helped many students, and I'll be glad to help you as well. So that's done. Let's continue with question number 3. I'm looking forward to see you in my class. Question number 3. A micrometer is used to measure 28.5 millimeters width of a plastic ruler. The micrometer reading reads to the nearest 0.1 millimeter. What is the correct way? What is the correct way to record this reading? Of course, you know that, of course, you can see the readings are given in meters here. And the measurement is in millimeters. You can notice that. Of course, you need to convert the millimeters into meters. 1 millimeter is the same as 1 times 10 raised to power minus 3 meters. This milli is a prefix, meaning standing for 10 raised to power minus 3. So, of course, you can convert millimeters into meters. And therefore, our 0.1 millimeter here, this reading which the micrometer reads up to, is the same as 0.01 times 10 to the power of minus 3 meters. And of course, you can write this one also as to power 2 as power minus 2 as 0.001 times 10 to the power minus 2 over meter. Now, you can also convert this 28.50 millimeters into meters, and what you're going to be getting is 28.50 times 10 raised to power minus 3, 10 raised to power minus 3 meters. And of course, you can also convert, bring this one to 10 raised to power 2. So this will be 2.850 times 10 raised to power minus 2 meters. And therefore, you can give this one as, because we are doing that, because the choices here is 2.8, 2.8, and the rest. So therefore, you can express this as 2.850 plus or minus this 0.001, and this is raised to power 10 raised to power minus 2. You can see both of them are raised to power minus 2 meters. So you check out the answer which is corresponds to this, and you'll find that the answer is C right there. Number 4. The size of a wooden block measured with calipers. We measure these sides with calipers in millimeters. Calipers measures length in centimeters. The lengths of the sides are measured as 20, 40, and 10. The calipers can measure with an absolute uncertainty of plus or minus 0.1 over millimeter. What is the percentage uncertainty of the calculated volume of the block? Of course, the first thing we do is get the volume. Volume is length times width times height. Width times height. In which case, this is going to be 40 times 10 times 20. This will give us 8,000 millimeters cubed. We know that for absolute uncertainty, the absolute uncertainty of volume divided by volume should be equal to the absolute uncertainty of the calipers, which is 0.1, divided by the measurement, which is 20 for this case, plus the absolute uncertainty of calipers divided by 40, which is this one here, and then plus the same absolute uncertainty of the calipers divided by 10, which is right there. Therefore, this will give us 0.005 plus 0.0025 plus 0.01, and of course this will come to, when you add all this, you get 0.0175. Now this is equivalent to this, so 0.0175. Of course, we want to calculate the percentage uncertainty. What is the percentage uncertainty of this? So of course, the percent uncertainty is the absolute uncertainty times 100. So it's same as 0.0175 times 100. Okay, of course, multiply both sides by 100 does not change the value. So this is the absolute uncertainty. This is a percentage uncertainty. So this will be 1.75%. That would be the percentage uncertainty of the calculated volume. Of course, this is approximately 1.8%, which is B right there. Number 5. What could reduce a systematic error? Two types of errors, you know, systematic error and random errors. Systematic errors are due to the measuring instrument, due to measuring instrument errors, among others. Of course, random errors are due to the experimenter, and therefore systematic errors cannot be reduced by repeating an average. Cannot be because always, if it is due to the system, if for example calipers has got a 0 error, you will not remove that 0 error to get a correct measured value by repeating and averaging. Therefore, what could reduce the systematic error? Systematic error can be reduced by recalibrating or calibrating your measuring instrument. Carefully calibration of the measuring instrument. So that is the only way you can reduce the systematic error. If it were random errors, of course, random errors you could reduce by repeating and measurement. But number 5, that is the answer. Number 6, the power loss P in a resistor is calculated using this equation. I don't know whether we have done this one. Okay. The percentage uncertainty in the power potential difference is 3. The percentage uncertainty in resistance 3. What is the percentage uncertainty in P? Of course, P is equals to V squared upon R. Therefore, the percentage uncertainty of P will be 2 times the percentage uncertainty of V plus the percentage uncertainty of R. Okay, this percentage uncertainty here. So this will be basically 2 times 3, right, plus 2. So this will be 6 plus 2, giving us 8%. Answer is C. Alright, that's it. Thanks for watching this measurement and technique topical video questions. Look out for more questions, as I've indicated to you. Look out for more topical questions in this site, Solved Papers. Solve as many as you can. If you need my help, get in touch with me in this site that I've indicated to you, solvedpapers.co.uk, and I'll be able to bail you out, and as you prepare for your 2021 and beyond AS physics exams. Cheers. See you in my next video.